Welcome to the first episode of Upstream, which is a new series where I will be having longer conversations about the data streaming industry. And in this first episode, I had the pleasure of talking with Yaroslav Tkachenko about the current state and recent developments of the Flink ecosystem. Yaroslav is a well-known figure in the industry. I've heard him being described once as an important independent voice, which I liked a lot because even though he's been building streaming-first architectures for many years, he's never been employed by a vendor. And I had the pleasure of meeting him in person in London earlier this year. We discussed recording something together, and now we have. Hope you enjoy. Thanks a lot for coming. I really appreciate you being here. Your newsletter is, I think, one of the very few that I actually read every one. You were also one of the first people writing about diskless properly.
Thank you for inviting, and happy to be that sort of independent voice and hopefully share things that are somewhat useful for the folks, and not just trying to sell one technology or one way of doing things, but like trying to really holistically understand what's going on in the streaming world.
Yeah, and you've just came back from Flink Forward, right?
That's right.
And you've already published about this a little bit. Can you share your experience and both the general vibe and what you specifically found interesting?
Definitely. It felt on a smaller side personally. So I did miss the Flink Forward last year, which was in Berlin, and it was a big event, 10th year anniversary. And then I think the one before was in Seattle, right after COVID. So again, sort of on the smaller side. So I went to that one. But of course, I'm comparing it with current or Kafka summits before. So definitely felt on the smaller side. A lot of engineers, right? Very, very little, salespeople or business-oriented people. It's just a lot of engineers, everyone is trying to understand where to go next. Honestly, right? I think we are somewhat, I wouldn't say it's a big milestone, but it feels like there's so much stuff going on. There's this AI craziness, right? We hear about all these acquisitions and layoffs and data streaming. I don't think it if you check Confluence valuation and if you follow the news, it doesn't feel like it's a huge win just yet, right? It's not something that truly went mainstream, and so everyone is sort of trying to understand for themselves. Am I in the right place? Am I building the right thing? Like, what's coming next? What's going to happen? Like, is Kafka and Flink sort of still a good standard stack, or should I look beyond? Yeah, so kind of felt a bit that. Talked to a lot of people who are between jobs right now and trying to understand where they can go. But on the technical side, some interesting announcements from VERA-X for sure. They've been working on a lot of interesting stuff. VERA-X, obviously, some of the AI primitives, the things like Fluss and delta joins, and it's quite a bit of stuff. If you want to unpack it, happy to kind of go deeper. But definitely like a smaller event, very engineering heavy, but had really good deep conversations there.
And it's interesting that Flink Forward is dedicated to the Flink ecosystem specifically, right? This is not,
yes,
I would say, a data streaming conference. It's a Flink conference. And Flink is, of course, by far the most important technology in the stream processing world. But we also see a lot of emerging technologies, all of them going SQL first. So I'm curious, what's your take on that? The SQL versus data stream API.
Mm-hmm. I think there are a few dimensions here, right? So there's definitely the interface, SQL versus let's say data frame versus something that's super low level imperative where you just create like process functions, but there are also some other dimensions, and Flink, for example, also has SQL support, and it's pretty decent, right? People build production applications. Like I know Netflix is really successful with adopting Flink SQL, for example. They have thousands of jobs, but all these newer data, like most of the newer databases, like Fildera, for example, they really advocate the IVM approach, which IVM stands for incremental view maintenance, right? So the idea is you declaratively define the outcome that you want, and then you let the engine to sort of optimize and create things in runtime for that. And it's not just streaming, really. If you look at, for example, Snowflake, they have dynamic tables. There are some other companies who kind of try to follow that approach. Maybe they don't even declare themselves as streaming engines. It's just computation, data processing. But if you really think about it, if you can connect it to a Kafka topic or like a data lake with lower latency, you get that. So I would think in terms of like several dimensions here, right? And the language itself, I'm a big fan of SQL because you can kind of learn from the decades of database research, right? So if you go really deep into databases, and I highly recommend, if you're interested, check out the CMU, Carnegie Mellon University's online courses and materials. They share a lot of interesting stuff. And if you really go deep, you can understand that people write PhDs on SQL optimizers and like really trying to understand, I have this 30-way join, like what is the best way for me to approach it, and how can I save, a percent of CPU here and percent of CPU there. So by going SQL first and going to this sort of more declarative approach, you do get advantages from databases. And of course, you can't always directly apply them. Like classic example is predicate pushdown. And if you have a streaming source like Kafka, you can't really do that, unfortunately, as effectively as predicate pushdown for like an object storage, right? But yeah, that definitely, like if you have a computation that's relatively complex and you express it in SQL, you can sort of have some level of trust that the engine will try its best to optimize it. So that's amazing, right?
Yeah, and to me also SQL is the way I think about data streams. So I'm curious, but right now Flink is an outlier that it does support SQL, and the announcements were around this as well. But it's the only one that it's a really good fit for complex event processing as well, right? Because of the data stream API, and people are doing like threat detection systems or complex events on that. And for this right now, it seems to me that this is the only solution, although Spark is coming into this space as well with actual real-time streams, no longer micro batches. Cool. And something that you've said...
Just to add, if I may, just wanted to add that SQL, you can definitely do a lot with it, but I don't think you can quite cover 100% of use cases, right? So you can probably get to like 70, 80%. And after that, there's definitely, some use cases where you need low-level access to state and timers, and those types of primitives. And it's really hard. But maybe if you follow some of the news from Confluent, and specifically, some Flink maintainers there, they're working on something really interesting called polymorphic table functions, or PTFs. And it's actually part of SQL standard, but now they're bringing it into Flink. And this will allow you to write essentially like an imperative program, something like a UDF essentially. But you get access to state and timers and all those primitives, and it can be easily used in the SQL statement. So you can have your custom join or custom aggregation or custom, operation. And it's sort of a bridge between, imperative and declarative worlds. And I think once that's fully, adopted and used everywhere, maybe we won't even need a data stream API, like lower level API, because you can just cover everything with SQL and PTFs.
Right. They are working on it. Do you know when did you start like reading that they are working on this? Like, do you have a feeling of how advanced the work is?
I would say it's it's already available in Flink, right? So it's not something that is, kind of internal. I think the latest version of Flink, which is 2.1 right now, right, or 2.2. I think we are in that sort of cadence right now. Yeah, it's already available. You can use it. I haven't tried myself, to be honest, but I heard from the author, Timo, that it's ready. It's ready for the prime time. You can definitely start using it. There are so many examples that they built and sort of demoed in a few events over the past year. So yeah, I would say give it a try and see what happens.
Hey, if you are enjoying this so far and would like to see more content like this, consider liking and subscribing. You said that the overall vibe is the question mark, right? And I've seen it as well in San Francisco. What I've heard is that a lot of money is flowing into AI, and the way I see data streaming in the next few years is kind of the lower layer, right? This is the data retrieval, data serving, and in general the data processing layer for whatever you want to build on it. Like it's if you can cost efficiently get real-time data, it's just valuable, right? But I got a similar, I would say, a bit of a concerned vibe from talking to people there, and the market is not growing as quickly as AI, and we've seen a lot of the AI bubble things posts recently. I'm curious how it will develop. You've also made a few interesting predictions, I think a year or 2 years ago, regarding how the data streaming platforms will develop. How do you see this realizing?
Definitely. I wrote that blog post. I think it was called Data Platforms in 2030 or something like that. And my biggest prediction was that we'll see some form of unification between both, compute and storage, but specifically on the storage side, unification of a streaming log like Kafka, and then more like long-term storage, like a data lake type of storage, and maybe even additionally some kind of fast key value database or like OLAP database or lookup storage. And so on the first two, it happened. So I am, I'm happy to say that prediction worked out. We see now Iceberg has been added as like a first-class citizen in a lot of the Kafka compatible systems. Confluent, Red Panda. Avon recently announced the open source extension for the the vanilla Kafka. So definitely makes a lot of sense. People still debating, should I copy the data or should I have a single sort of zero copy approach or what's best? But ultimately, what I really want
here. Do you have favorites?
Look, I really would like the zero copy approach to work out, because it just means we can save so much money on, the network and the storage. But I understand that you can't really easily store data in one format that's available both for row access and columnar access, right? And I spent some time this year, building on top of Arrow and sort of trying to move streaming data into columns, which probably we'll touch base later. But yeah, it's really hard and it's really compute intensive going through this like row to column to row conversion all the time, and have completely different compressions and encodings. So maybe some smart folks will come out with like a new format that's there are some databases that done some interesting research, but they still do the copy, right? So you can like have different versions optimized for different query patterns, and yeah, that's the reality.
And even all of the diskless solutions that are there, they are persisting small batches in object storage, but then every solution has a compaction process that takes care of you have the right optimized way to persist data, and then you need to prepare it for reads, even if it's like row oriented format, right?
Yep.
Yeah, so I'm very curious, like how the conversation will develop, and it's really cool that we see a lot of products experimenting with different approaches. That's good for the industry, definitely. You've also, I'm bringing up the topic of diskless because it's it's something that I'm really hopeful about. And you've worked with diskless directly for a while, right? You were the early adopters of WarpStream, as far as I understand the situation.
That's right. Yes.
When did this start roughly, and what was your experience?
I'm curious how much I can share, but I think I can share quite a bit. Yeah, it's funny. I talked to the founders of WarpStream before they even started working on WarpStream. I think they were still a Datadog at the time, and they sort of approached with this idea of building an engine that can alleviate some of the common Kafka issues, specifically the cross AZ traffic. I think that was their main goal, and I shared all the feedback about this idea of streaming first architectures and basically storing data forever in a Kafka topic, and what it means in terms of the control plane and the compaction and all these other things. So it was interesting to work together initially. With this type of use case, right? It wasn't a classic, Kafka use case where you just put data for a few hours or a few days. Maybe it's a lot of like unstructured data. We have columns. Doesn't really matter. I really wanted it to make it possible to just just set infinite retention on all the topics, not think about it at all. Just assume that they always have access to the data from the same interface. And I was so hopeful that this data will just be available in a data lake format eventually, right? Which is not the case, unfortunately. That's not how things worked out. But conceptually, I think it just makes all the sense. You store data in the object storage, very cheaply, and then you can access it different ways, query it different ways.
I think I either read something from you or from Blue Sky. Is this the name of the company?
Gold Sky.
Sorry, I thought Blue Sky for some reason. Yeah, so I think I've read either a customer story by WarpStream on Gold Sky or something from the Gold Sky side. I'm not sure, but the story was very extremely positive, right? That's and what were the pain points that this was solving?
The previous vendor, and I'm not going to mention their name, but it wasn't vanilla Kafka, right? It was something else. We just had some problems with that sort of streaming first, what I call streaming first architecture, where you're essentially keeping all the data in your Kafka forever, right? And when you start, with smaller sizes, it kind of makes sense, things work. But then eventually you just add more and more pressure on the tiered storage system, which you absolutely have to have in this. And I really believe that it can work because honestly, a lot of the use cases for Gold Sky was mostly tailing data from the end of the topic, and then occasionally you would go and like reprocess a bunch of stuff from the beginning, and so you don't really use tier storage historical data like as much. But unfortunately, with that company very early on, I think we were one of the very very aggressive customers who used the tiered storage, right? And we have had some bugs, some outages, some problems. Ultimately, it mostly worked, but there were still some edge cases and some issues where I remember if you want to rewind your consumer to a specific offset using the timestamp, you could like time out because that timestamp to offset conversion, it was quite compute intensive. And this is not something that WarpStream has problem with, for example, because they store metadata sort of separately. And you don't need to go through the Kafka protocol for that. Yeah.
If I recall correctly, your volume was problematic, right? That you were just moving so much data that warp stream. I think that this was coming from them. That this was the signal that forced them to rethink their scalability sailing, and forced some change in the logic.
And to be honest, Gold Sky is still a startup, right? And in terms of data volume, it's on a smaller side. I used to work at bigger companies like Activision and Shopify, and the throughput was definitely higher. But because Gold Sky stores all the data forever, right, in Kafka, it keeps growing, and you need a more sort of elastically scalable system, both on the data and the metadata, to be able to support it, right? So it wasn't just the throughput, but the fact that it's stored essentially forever.
Right, and you've worked at Activision and Shopify for quite a while. I think today I found the earliest talk of yours from 2018 about Activision. So it's you were early. And what I'm curious about is what pain points related to the usage or adoption of data streaming have you seen frequently? Yeah.
And I would like to sort of categorize those into two big categories. One category is when you use data streaming mostly for real-time ETL, right? So you have some sort of data lake, data warehouse, you have classic, BI tools, you build reports, you maybe build some views, but it's mostly for internal use case. Maybe you train ML models, stuff like that. And that's one category, and it has some interesting challenges, which are, I find, mostly organizational and people problems. And the other category is when you build real-time, what I call data products, right? So something that you put in front of a user, maybe it's user-facing analytics or something else, or maybe you build microservices sort of with the data streaming tech. So it's something that's definitely more user-facing, that needs to be online 24/7. You're really sensitive to downtime and outages, where with the real-time streaming, real-time ETL, maybe if the pipeline is down for a few hours, you just sort of let it catch up later, and your final report is maybe updated once a day, so you're fine. And with the first category, it's really the organizational problem, because you hear the concerns like, why do I need streaming, right? I can just simply, run my batch job and maybe ingest a bunch of data once in a few hours, and then run another report, and then, everything is going to be done overnight. And honestly, that's really reasonable. And if your use case is literally just building a dashboard that is viewed by a handful of people, maybe you don't need to invest into Kafka and Flink and all these technologies, for sure. But I see a lot of value when you have that internal data platform. I see a lot of value in streaming as the sort of unifying data integration or data orchestration mechanism. Because honestly, data streaming is still the best way to integrate different systems. And I like to mention this book, which is really old, more than 20 years old, called Enterprise Integration Patterns, or EIP. And if you worked in enterprise Java shop with Spring or Hibernate or Apache Camel, maybe you kind of understand what I'm talking about. But honestly, that book is still extremely useful nowadays. And maybe 70 or 80% of the patterns that they describe there, they still apply to Kafka and the streaming that we have. And so I think data streaming is just such a powerful way to integrate systems. And when you build internal data platforms, you will have to do that. Maybe not immediately. Maybe originally your data source is just a clickstream data from an endpoint you stood up, or maybe it's a CDC data, right? But eventually, when you keep growing, you will definitely start onboarding new data sets, new use cases. Maybe you acquire new companies. Maybe you will have use cases where some of that internal data has to be exposed to your partners or third-party customers. And honestly, it's still the best way to go about it. I'm pretty sure.
Yeah, I have the same opinion. I've worked on a few projects where Kafka was used this way. And out of all of the use cases that Kafka used to be used for, I think that the two that will remain is one is orchestrating event-driven microservices, and the other one is real-time data integration, right? Because it's getting moved out of the analytical space, and Fluss is one of the solutions, but Databricks and Snowflake, they are implementing their own streaming solutions, stream storage solutions. But if you want to go real time and data streaming, maybe Northgard. We'll see how the scene will develop. But for low latency and this kind of universal way of moving data around, it's natural that you have something that's really right optimized. It can get really low latency.
And briefly on the second category, I think there, when you have something that's user-facing, that's running online, powering real experiences, the most important part is actually sort of embracing that SRE mentality. It's very common that you have data engineers who used to build those internal data platforms now have to build those user-facing applications. And maybe they used to running, batch jobs, and you show up at 9 a.m. and you check failures from the night, and you maybe restart some jobs. But here, but here you have to carry a pager, right? You have to really design things from the resiliency perspective. You need to think about how you react to potential failures. So you're really talking about more like operational heavy mindset, maybe hiring some folks who know how to run systems and not necessarily just build ETL and data pipelines. And that is a very common challenge, especially in bigger orgs where you have a team that maintains certain data sets, maybe those mostly internal, and now they need to build a product that's going to be put in front of the customer, right? And of course, in real large orgs, you typically have teams that can provide you with that serving layer, and they sort of manage that. But still, you are on the hook to now provide those data sets in real time, or mostly real time, and you have to do a lot of like resiliency work and have good playbooks and on-call rotation figure out and all of that. So it's also a very common challenge.
And then we are moving into the space of data products and data mesh, and in general, like the data teams kind of adopting a lot of the approaches that the operational teams just have imprinted from year one.
Exactly.
But it's another problem. I mean, it's just a huge new topic about which maybe we'll talk a bit more deeply someday. I've mentioned Fluss. You've mentioned Fluss as one of the announcements. I've been following the project for a while. I think you were the first person that I've heard about it from. Quite a while ago, and VERA-X, right? The two big announcements. I'm not. In my eyes, these are the two big ones, right? There was also the AI features, but I'm just not in this space, so I'm not getting excited about about this part. Can you comment on how, talking to people, how was this received, and how do you see the impact of both? Maybe let's start with Fluss, because I want to kind of separate this two.
Sure. And honestly, the reasons behind Fluss, right, they are solid. And there was a talk at the conference, something like 7 Deadly Sins of data streaming, from Yanis, and you definitely agree with everything that's been said. You just keep nodding and yep, that makes sense. I've seen that. That exactly is a problem. And Fluss seems like a really good solution. But I have this sort of chicken and egg problem where, in order to use it, you have to migrate your existing workloads. Unless you're starting the company from scratch and you're very early and maybe you adopt Fluss at the beginning, but then you have sort of the data integration problem to figure out, because Fluss still does not speak Kafka. And that's the biggest issue, I think. It's really much harder to migrate or adopt it, because you basically have to go always through Flink or Payment Iceberg, like a few sort of built-in connectors that exist. And if I want to, if I want to play with it, if I want to build a POC, it's going to be really hard without getting that sort of Kafka support, right? And so how do you get more adoption without letting people to easily migrate, right? Not entirely sure, but based on my conversations, it doesn't seem like Kafka protocol integration will even happen potentially, right? Because honestly, it's just so different, right? What you can do in Kafka and what you can do in Fluss, even things like schematized data sets and like more tabular formats versus just raw bytes. Of course, you can bring the schema registry and sort of go through that, but at the protocol level, they're very, very different. And so I think it's a great project, and I really hope it's going to be more successful and sort of more popular and getting adopted more. But not having that easy Kafka migration path, I don't know. I don't know how to do it.
Yeah, the way I see it is that it's not an alternative to Kafka, but maybe another stream storage solution for the analytical data stream specifically, because Kafka can get just like different latency category, and it has this massive ecosystem. But the way I see the biggest value of Fluss is if you already have Flink pipelines that have massive state, then you can get a lot of benefit from that. And also if you are onboarding, especially if you are in Flink ecosystem right now, but as far as I know, Spark support is on the roadmap, and if it is delivered, then this would be huge, because this could serve as the general hot layer for the lake houses, right? And if you already are using Flink, then this is a natural way to build new latency sensitive data processing pipelines. And yeah, they have tiered storage with Iceberg right now. And as far as I've explored it, it sounds really robust, and because they support both maintenance on the Fluss side and Flink, because if Flink is doing the compaction and functions, and also they can work with external maintenance. So if you are running Dremio or Databricks or whatever, you can still using Iceberg. So the way I see it is, you can plug it in as a hot layer for the lake houses that are normally operating on batch mode. And yeah, right now only with Flink, right? But if Spark is supported, then this could really go mainstream.
Yeah, and it's a good point. Honestly, sort of an adjacent technology to Flink, right? Where maybe have like a complex set of data pipelines, and you want to, what I call materialize your streams in certain data storage. But then if it's just that, why not put data into ClickHouse or even Postgres? Honestly, because if it's a subset of data, you can store a lot of data in Postgres nowadays if you use a managed service, right? And honestly, I think that's something that's been missing so far from the data streaming industry. Like, simple OLTP database can be a really powerful data sink, data destination, and sort of a companion to your data pipeline. And so, yeah, then you sort of start to compete with that, because adding a new technology just as a sort of a hot cache or like a derivative data store, that's always going to raise questions about the budget, about the investment. And then, as I said, why not just put the data into a faster database then? Yeah. So if you're not replacing Kafka completely, so still questions.
Awesome. Thank you for all of this. It's a very interesting take. The other big one, VERA-X, right? I've learned about vectorized processing from you because you've been building something similar, but also the many other stream processing engines, they already use vectorized processing. So assuming not everybody knows what this means, could you give us a short introduction into what's the value of vectorized processing, and then how does this apply to the Flink world and maybe a wider stream processing or data processing world?
Sure. And I think vectorized is a really cool world. Like word. It sounds cool, but I think the right term is columnar. And it kind of reflects things a bit better. So usually in typical, big data stream processing frameworks and streaming storages like Kafka, Flink, Apache Beam, Spark, and all the engines before that, you operate with rows, right? So you have like an event or a message sitting on a Kafka topic, and then you consume it, and you do something with it, you consume the next one. You could be batching them internally, right? So when you pull data from Kafka, or when you maybe shuffle data between Task Manager nodes and Flink, you could be batching them together, but you still sort of operate on one record at a time, and the data is flowing through the system one record at a time. And about maybe 10 years ago or so, in specifically analytical databases, the research behind analytical databases, there was this big shift. What if we on a database level, store data in columns, maybe even more than 10 years ago, right? And I think it started there. And if you look at all the modern, like really fast analytical databases, like ClickHouse and, Snowflakes and data warehouses and all of that, like they all try to store data in columns. And it just makes a lot of sense from an analytical perspective, because with columnar storage, you get really good compression or encoding, right? You can have like a column of small digits, and you can encode it very, very efficiently. Or you can have a small, like enum like keywords, and you can just encode them with a dictionary, right? So just store little bits, and this is really useful for storing and processing as well. So there are two things: vectorization and CPU caching. And vectorization is, it's a name that really stands for one technique that modern CPUs do is SIMD instructions. So single input, multiple destination, I think that's how it abbreviates. So it's you can run one CPU instruction to process several records at a time. So imagine if you do sum, you have like two sort of vectors on both sides. If you don't have that SIMD instruction, you have to sort of go and sum them one by one. With SIMD, you could be processing like 4 of them or 8 of them at the same time. And obviously, that's going to speed things up quite a bit. So vectorization is just, I think, sort of an alias behind processing data in vectors and leveraging modern CPU instructions to really optimize it and speed it up, right? And that's extremely common in databases, analytical databases, but now it's sort of coming more into streaming world as well. And the other technique, like why columns are so beneficial for data processing, is CPU caching, right? So modern CPUs have many levels of caches, and you really want the data to stay at the topmost cache as soon as possible, because you have very quick access compared to going to a lower cache or going to main memory, right? And when you process data columns at a time, you also can leverage the fact that, again, modern CPUs, they prefetch data in blocks. So when you process, a few records in the beginning of the column or the vector, the processor will give you, like, it will prefetch the data in the next block. And so when you go, imagine you have like a tight for loop that's going through the vector values. When you go to element number 8 or 9 or something, right, the next block is already prefetched by the CPU and it's already available in the cache. So you can go really quickly. And there's a whole bunch of other stuff. Like if you're interested, I'm really fascinated by what modern CPUs can do. But TLDR, if you represent data using columns, not rows, you can get a lot of benefits from CPU caching, SIMDs, probably some other things as well. But unfortunately, it's not always easy to represent the same operation that you usually do with rows using columns. So it's still not a a super well adopted technology, and especially in the JVM. JVM only added support for CMD instructions using this vector API, I think in version 20 or something like that. And even in the latest 25, it's still sort of marked as beta. So if you stuck on Java 11 and Java 17, you just don't have access to that, period, right? And that's why people maybe start to look more into native languages and going back to like C++ or maybe Rust to get access to all those like modern primitives.
Yeah, and okay. I mean, to me, the benefit is clear. All of this just makes sense. And yeah, I've heard about Project Flush from you as well. That was developed at Alibaba, and seems that VERA-X has, like you said, it taken a fork probably and implemented this as part of the platform. So, and I've read one article about it. It just makes perfect sense, right? So now we have a product coming from VERA-X that's, if I remember correctly, they were, oh no, I don't remember the numbers they provided, but the efficiency gains were really huge. You've also published, yeah, and to give a short intro, you've built Iron tools, right, with and Iron Vector, which is as hopefully I recall and represent correctly, but it's a Flink library that you can plug in that will substitute some of the operators for the table API and SQL API. For specifically like to replace them with this native vectorized processing, right, and columnar processing.
Yes.
So a beautiful idea, and the thing that kind of differentiates it from Vera is that you can plug this into your own Flink, right? And how is the development going? I saw you've published some benchmarks, I think a month or so ago, but if I recall correctly, right now only some operators are implemented. So how is it going? How challenging it is?
Sure.
If you could maybe update me a little bit on the situation.
Yeah, it's still relatively early, right? I know, Alibaba folks worked on Flash. They've been working on it for a couple of years, and they have dedicated team, and they have resources, and they, really, really smart engineers. So it's hard to compete with that. Like I admit, they definitely, ahead. But what I discovered is that nowadays, if you fully embrace, the Rust ecosystem, there are so many tools out there that you can use as building blocks, right? So Apache Arrow, for example, it's not a Rust technology, but it's sort of a columnar data format, but it has really good support both in Rust and JVM, right? So if you want columnar storage, you can just use Arrow. And for the actual execution runtime, I also use something that can be used as building blocks. It's called Data Fusion, Apache Data Fusion. It's a Rust-based engine that uses Arrow to implement your standard database operations, and people have been very successful building databases or even streaming engines on top of Data Fusion, right? So I guess I have a bit of an advantage where I take some of the building blocks and sort of try to integrate them with Flink, but integrating with Flink was still really challenging. It's you go really deep into like how does a network shuffle actually happen in a Flink test manager. How do you serialize and deserialize the bytes? And yeah, it's a fun, like it's been a really fun project, and so far I've built sort of a stateless operator support. So if you mostly do like select statements with projections, filters, maybe use some functions, you have a where clause. It does support all of that. So if you go into more advanced like stateful computations like aggregations and joins, that is still not implemented, but I have a pretty good sort of idea on how to go and build it. And yeah, it's been fun. It's definitely a challenging project, but I also kind of I definitely stand on the shoulders of giants, like Alibaba Flash, and it was very interesting to see a lot of validation, based on what they shared. I was just like, again, kept nodding when I watched the presentation. Yep, that is a problem. Yep, I done it this way. Yep, yep. So it's good to have some validation that it it's worth doing, I guess.
It sounds, yeah. I mean, you're saying we're standing on the shoulders of giants. I mean, we all are, right? The industry started in the 60s.
Yep.
And yeah, we are all slowly progressing forward. So like the vectorized processing is one way to make Flink faster, but you also have other tools, and also you have years of experience. But maybe for people that have started working with Flink not that long ago and are facing their first performance issues, do you have any generic advice on the tunable knobs or maybe things that are worth looking into on how to tune just regular Flink performance, and what can help?
Definitely. If I share something specific, like go and tweak this, this config value, honestly, it's going to change in a couple of years. So I have a couple of things that are more, stable and going to be valid. First of all, really understand how to use a profiler, right? And I wrote some posts about async JVM profiler. It's a great profiler. It allows you to build flame graphs. So you run it on a task manager that may be having issues, right? Or you think that things are slow, or data is moving slow. The first thing you do is you measure, you run a profiler, you build some flame graphs, and you try to understand them. It takes a bit of time to sort of get that experience, but this is not specific to Flink or even JVM, right? Just like the industry level, like profiling is such a common if you care about performance, right? So really try to get good at it, and try to get good at reading source code. So check out the Flink source code, check out the branch with the version that you use, open it in the best IDE you can get a hands on, JetBrains, and really try to understand how things translate between what you see, in Flink UI and logs and metrics and the source code. And I've seen such a different levels of experience, and I've seen some staff level engineers who didn't understand how to use this at all, and they were just like completely helpless, and they would spend like months trying to fix a relatively simple issue in like a file sync, where you can just open the source code, understand how the file sync works, and like, oh, okay, I just need to do like an extra shuffle here between I write it. And I've seen some juniors, like interns, that were really productive because they actually they could just open the source code, understand what's happening, and the more you do it, the more sort of you build that muscle, and you combine it with the profiling. And these are like extremely powerful tools, not just for Flink, but in general. And if I say something Flink specific, if you use any kind of stateful pipeline where you store state in RocksDB, try to get the fastest SSD you can get. So if you on AWS and use something like EKS, or you deploy it with EC2 machines or whatever, don't use EBS volumes. Go for instance level storage, which is considered volatile, right? So it's sort of it goes away if you restart the machine, but the data is already stored, in safe points or checkpoints, so you shouldn't care about that. But I've seen a huge difference between running like an EBS disk for your RocksDB storage versus just an instance level like fast SSD. It's like maybe 5x difference. So you really should try to get your hands on the fastest SSD you can get. So
sounds awesome. Very general, applicable advice. I was kind of prompting for this to get a nice short that I could use to to promote this. Awesome. I think that we've been talking for quite a while. I have tons of material.
And it's been fun. It's been fun. Thank you for inviting me, and we should do it another time.
Yeah, I would love that. Thank you very much for the trust and your time,
Sure.
and for all that you've said. Great talking to you, Yaroslav.
Likewise.
Have a nice day. Bye bye.
All right. You too. Bye.